Hi, everyone, and welcome to another episode of Pathfinder, a podcast by Payload, the leading digital media company in the space industry. I'm your host, Mo Islam, and today we're joined by Pari Singh, the founder and CEO of Flow Engineering, an LA and London-based startup bringing automation, integration, and collaboration to the hardware engineering process. Before we begin today, a brief word from our sponsors. SpiderOak's Orbit Secure software is designed for hybrid space operators struggling to manage the chaos of securing data flow and access to and from tens of thousands of small satellites in low Earth orbit. Using a unique combination of end-to-end zero-trust encryption and blockchain distributed ledger, Orbit Secure allows your mission to orchestrate and secure Earth-to-orbit, orbit-to-Earth transmission, communication, and storage of sensitive data across even the most complex and unsecure hybrid space environments. To learn how Orbit Secure can bring zero-trust security and resiliency to your zero-gravity environments, check out SpiderOak at www.spideroak.com. Pari, thanks for being with us today.
Thanks for having me. It's awesome to be here.
So you have a very interesting story, and I want to jump right in. Your company, Flow, was at one point originally, in some way, shape, or form, was actually building rocket engines in London.
Yeah.
So tell me about that and the transition to where it is today.
Yeah, we have a pretty crazy story, and we made the mother of all pivots from a hardware company to a software company. So when we started out, we didn't actually intend to build a company at all. We were young engineers that were deeply passionate about building hardware really quickly and getting stuff to market. And then we went to the industry. And when we went to industries, we went to defense companies, traditional oil and gas companies, energy companies. And what we saw really made us quite sad, which is the traditional current paradigm of doing engineering is incredibly slow, incredibly painful, incredibly expensive, and isn't really doing a good job at letting engineers do what they do best. So what we said was, hey, can we build a little corner of the universe where we design rocket engines? But rather than just designing the rocket engines, we reinvent the philosophy behind that. So what we had was a company called the Rocket Company, and we were the fastest design consultancy for hybrid and eventually liquid rocket engines in the world. Our competitors could go from requirements to design in 12 weeks. We told customers we could do it in 2 weeks, but actually we could do it in about 3 hours. And our secret sauce is that we built everything into this giant MATLAB script and broke that into sub-functions and gave different people functions. And then we tied that into a CAD model, NX, through their APIs, driving dimensions. And then we run that into CFD, computational fluid dynamics, and FEA, solid simulations, and then loop that back. So we can put a new set of customer requirements in, hit run, let the computer do the work, come back in 3 days with a bunch of different perturbations of designs, and then just pick the ideal one. And every single time we did that, we calibrate the 0-day model so we could do it faster and faster and faster. And we did that for about 12 months. And at the end of the 12 months, we were generating revenue. We had customers in the US that loved us, that used us for low TRL, quick and dirty engines. And we went out to raise our first round of funding. We said, hey, look, engineering's broken. There's going to be a new way of doing engineering, a more agile, integrated software approach to doing engineering. And the people that do that are going to be massively more productive than anyone in the industry. And we've done it for engines. And someone's going to do it for airplanes, and someone's going to do it for wind turbines. And these people are going to win the next era of engineering. And our investors sort of sat us down. We were young, naive, ambitious, but we didn't know what we were doing. And they said, you don't really know what you've invented. What you've invented is a new approach to doing mechanical systems engineering. And if you can find a way of formalizing that and putting it in a box and giving it to your customers, then you can solve the problem that you started the company for, which is to help the entire industry move much, much quicker and really bring that design back into engineering.
So I want to go back to the college days, and walk me from college Pari, or university, I should say, to where you are today. So like that arc, because we haven't talked about it yet, but if you're starting a rocket engine, a company building rocket engines, like there's something behind that I want to hear a little bit more about. So how did you even get to that point? And tell us a little bit more about your story.
Well, it's an interesting one. I became an engineer because I wanted to build machines that mattered. It was really, really obvious to me going into university that the world had a number of key issues like climate change, overpopulation, sustainable energy, and that we had to solve these problems through mechanical engineering, through what I call engineering. And to me, it didn't seem like the world agreed with that. Because if you looked at the 10 most valuable companies in the world, they were all software companies. And that makes sense to me, and it jarred me a little bit. And I sort of began exploring. To me, the hardest thing I could find to do was to design rocket engines. I wanted to test my chops. So I started designing hybrid rocket engines at Imperial College. And I started with just me and a couple of mates, and that grew into a team of 30. And that's really what kicked the whole thing off.
So this was 2010,
I'd say.
2010.
Yeah.
Okay. No, I'm just trying to frame it from where the commercial space industry was at the time. Okay. So this was quite early.
This is early days Rocket Lab, early days Firefly, SpaceX. Yeah. I think had just launched the Falcon 9, and they just archived the Falcon 1. It was that sort of era of nascent early commercial space COTS.
Okay, and was the plan to just build engines, like sort of like what I think Ursa Major does, or was it more like build a rocket?
Yeah, great question. The really honest answer is I was a young, wide-eyed, naive, ambitious, die-hard engineer that wanted to work for SpaceX, and ITAR got in the way of that. So I called up a friend who I knew was working at SpaceX. And I said, you tell me what the roadmap is for years 5 to 10, and I'll just do the research for it. And I'll do it here, and I'll just do it commercially, or I'll do it through academia. And I would give to that mission in that way.
Right.
So originally it came out of wanting to work for SpaceX and then saying, hey, let's boil it all the way down to something we can actually deliver as a product. And the most complex, the highest cost, and the most sort of important element that we could find was a rocket engine.
I see. Okay, super interesting. So then, what was the inspiration? Okay, so you were building rocket engines. All of a sudden, you realize you've built a software tool that will allow you to iterate faster. Yeah. And all of a sudden, you have an investor saying, "Hey, don't do any of this. Just build this tool." So, like, what at that time inspires you to say, "Okay, this is the you went from building hardware to now building a software tool to help hardware to help engineers, right?" So. Was that ultimate, like, I guess, did you land sort of where you thought you'd land, or walk me through a little bit of the inspiration for building the business?
Absolutely not. The sort of playbook we wanted to do was to sort of copy SpaceX and Rocket Lab and say, hey, let's try and replicate some of that, but let's do it with none of the money and none of the experience, which was a recipe for disaster. But the real reason we started the company is we were frustrated with tooling in the engineering industry. And that's what prompted us to create these tools in the first place for ourselves, because we were sick and tired of what engineers have to deal with day in and day out. If you look at software engineering tools, they're magical. Look at design tools, they're magical. You take any industry, gaming, video game design, animation, the tools are really fantastic. You look at mechanical or systems engineering, the tools are shockingly bad. So I think it really came out of that frustration, the wanting to do more as an engineer and being held back by tools.
Why do you think that is? Why do you think that you've seen innovation in design and software and collaboration tools in all these other industries? And I think you've mentioned once that hardware engineering hasn't evolved in the last 30 years. Why is that why is that the case, do you think?
Oh, it's a tough question. I doubt I'd be correct with whatever I say here. Obviously, the complexity behind this is really large. I think there are probably two major driving factors in it. For lack of a longer way to say this, I think our industry is basically an oligopoly, where you have a couple of major players that build CAD and PLM software, and they've dominated the industry for years in very, very entrenched, multi-million deals with Airbus and Boeing, and they've really, really won that market. And reason number two is, until recently, there wasn't really a reason to do things faster. If you look at Lockheed and NASA in the 80s, 90s, and early 2000s, we were kind of happy with the pace at which we were delivering at, and there was no real incentive to go faster. Then think about COTS and the commercial wave that's hit us. There's a real economic incentive to move more quickly, and there's money tied to that. And that's created this realization that, hey, our tools aren't good enough, and we could be going so much faster.
Yeah. So what is Flow's product set today? What, as a potential customer, like, what can I buy?
Yeah, so Flow is a requirements management tool built for the fastest moving agile teams. Fundamentally, we think there's been a core change in how engineering is done in the space industry, but also more widely across other verticals. And this change is moving from a more traditional, what I call old school, multi-year, sometimes decade life cycles, to much quicker agile, build, test, fly cycles. And that actually is a complete revamp in the playbook, which changes what users need day to day. The old school requirements management tools like IBM Doors that most people hate, are 100% not a fit for this new way of working. And what we actually see happening is most modern agile engineering teams end up trying to build their own tools in things like Jira or Airtable or Notion. And they need to be a bit more sophisticated, built for this new workflow of agile.
I have a more sort of maybe existential question is the best way to say it, but like ultimately, like, you know, if I was being devil's advocate, right? Like, why does a software tool or a software tool like this matter? You know, we up until SpaceX, one would argue that the pace of innovation in space had really slowed down. We still had innovation. SpaceX became SpaceX, I think, well before you had a lot of these engineering collaboration tools. I don't know when Warp Drive was created for like SpaceX ERP system. I think it was like something like 2012. But at that time, they'd already built the Falcon 9. They'd already launched, right? So, like, you know, why do you think ultimately this matters?
I would sort of agree with you, but I'd say it's not the tools that make engineers great. It's engineers' paradigm and culture and philosophy has changed, and they need the tools to be able to back that up. So if you look at how SpaceX operates and the culture in which they operate, and you take someone from NASA that's been there for 20 years and you put them in that environment, it scares the crap out of them. Because all the fundamental things that you learn to do at NASA and the sort of perception of risk is wildly different at SpaceX. So what SpaceX basically did is took a software playbook. Elon came out of a number of software companies and said, hey, we can do this faster and we can do it in a more agile way. And he built an agile playbook for the hardware engineering industry. And that agile playbook is incompatible with tools like SAP and IBM Doors and tools that are really built to avoid change. And you need something better fit for it. And Warp Drive is a great example. So for the people that don't know, Warp Drive is SpaceX's internal ERP tool. It started out as an ERP tool and now basically is an end-to-end tool that captures everything from requirements all the way down to bill of materials and manufacturing. And the reason they built it themselves isn't because it's cheaper to do it than buying Siemens' PLM or Dassault's PLM. The reason they built it is the tool they built is actually wildly different to the tools that exist in the market today because their processes look different.
That's interesting. So do you expect companies as they become, well, I guess it's a bit of a new paradigm, but like, do you see more and more companies as they scale, as they grow, as they become, much more profitable and as they raise more money, like take the SpaceX approach of let's build Warp Drive, or like, hey, there's a lot of great tools like Flow that exist already. Why do it ourselves?
Yeah, I can sort of talk you through what we see today. There's always going to be a build versus buy decision, and engineers like building stuff. We just do. The question really should be is where is our core competency as a business? Is our core competency building satellites and launch vehicles and nuclear reactors, or is our core competency building software for that? We think we can build a better, more sophisticated tool for many different verticals. So we see that people end up building a lot of tools in Jira because they have no other option to. And then when they meet us at Flow, they're like, where have you been? Like, why weren't you talking to me 2 years ago? Like, I was desperate for this, and I spent $1 million in R&D off of a NASA contract to build this internally. And they're even going as far as giving us the source code to say, hey, take what we've built and go further with it and give it to the world.
Right. How does Flow make money today? What's your revenue model?
We are a SaaS company. So we don't make money in the way that Siemens makes money with multi-year cycles and high upfront installation costs. We're a SaaS tool. Unlike most of the SaaS tools in the market for our industry, you can go online today, flowengineering.com, press sign up, start using it, and have it, and be able to use it and deploy it through the team completely for free. We think the best in-breed software approach that's come from other industries has to trickle over to our industry. Because it's so much more effective, it's so much faster, it's so much better for the end user. And we believe we're one of the early pioneers in making that transition happen.
So you mentioned nuclear reactor. So I have to ask, it sounds like aerospace is not the only area or sector of the market that you're focused on. Is that right?
Yeah. So if we step all the way back, the reason Flow exists is, as I mentioned, there's this new agile approach to doing engineering. And this agile approach, I think, really came out of the space industry. It came out of the early days of SpaceX, other teams moving really quickly. I'd argue if you go all the way back to the SR-71 Blackbird era in the 60s, out of Skunkworks, they were working in actually a quite agile way, and we lost that way. But this agile approach to doing engineering has come out of SpaceX and modern space, and it's trickled into other industries. It's trickled into automotive. It's trickled into nuclear. But we're also seeing it trickle into things like medical devices, trickle into aero for commercial aeroplanes too. And you're seeing all of these different industries start to iterate at a pace that we've just never seen before.
How are you thinking about go-to-market, right? You're talking about, yes, engineers in effect at the core, right? Who they are, they're pretty similar, right? In terms of like habits and what they're looking for in job opportunities and what they're looking for at the job site. But in general, like these are very, very different industries. So how do you think about go-to-market?
I kind of disagree with the core assumption. I'd say designing an aeroplane and a car and a rocket have a lot more in common than designing a software package, right? If you look at the software engineering industry, might be a great example. If you build fintech software, or you build procurement software, or you build requirements management software, you're using the same core tools and the same underlying philosophy and the same version control platforms and the same testing platforms. Because fundamentally, what we have to do is build a product that has a really good reliability and get to market as quickly as possible. So actually, this requirements-driven agile workflow, we're seeing pioneered in the space industry that has now had arms go much further.
Oh, interesting. Okay. How are you converting customers that, so there's I think there's two types of customers. There's like, let's just say that there's a new startup who is very open to, efficiency and new ways to kind of collaborate and taking a first principles approach when they're building their business, right? And then you have your larger customers, we won't name them per se, but who have a system and way of doing things and processes that they've been doing for years and years and years and years. Let's maybe talk about that customer. How are you converting those customers from the old way of engineering to adopting your process?
Well, let me give you a story.
Okay.
We sold to a UK-based British supercar company. They have a supercar division and they have an F1 team. I can't say who it is. And we were
our car enthusiasts will probably figure out who you're talking about.
And we were in there day in and day out, and we were preaching, and we were like, you are what I would define as old school. Because you are old school, the delta and the amount of money you'll save and the amount of pain and cost you'll save is 10x more than a more agile team. And our learning from it was we, as a software company, are never going to be able to create cultural change inside of a company, ever, full stop. So we don't try. We want to work with the fastest moving teams right on the frontier, whether you're building nuclear reactors or rockets or satellites or in-space propulsion. If you are taking this agile approach, it hasn't come from us. It's come from the market. The market is saying, I want this quickly, I want this cheaply, and I'm willing to take a bit more risk to be able to do that. And the companies that act on that are going to become the most profitable and successful companies of the future. And the ones that don't are going to struggle and probably die out. I think you're seeing a bit of that transition happen in certain companies. Blue, for example, is going through a leadership transition as we speak. And they seem to be pulling it off. They seem to have the intent to say, hey, we were a little bit more traditional and we realized we need to work with a bit more agility. That's a sort of edge case example. I don't think it's going to be a common pattern, but you have seen traditional industries convert to the new way if there's enough commercial pressure.
Yeah. So is this automaker is working with you?
No.
Not yet.
We failed to convert the culture of the company.
No, I understand. Maybe they'll move up the F1 rankings a little bit if they were to work with you. We won't get into that. All right. So talk to me a little bit about the philosophy of Flow itself. Like internally, like how are you building the platform? Like what are the steps you're doing to iterate the product based on the feedback that you're getting from customers?
Yeah, awesome question. I think we take a fundamentally different approach to most engineering teams that are building similar types of software. As you've probably seen in LA and in the wider new space community, there's been a number of software players that have merged as a result of this change. Our core belief is that we build products for people, and we only care about the end user. We do not care about the decision maker. If you look at Siemens and Dassault and the traditional players of the game, they would build an incredible product that would sell really well to a chief engineer who would use a product once every month. And the end users would really struggle with that because actually they were second or third grade people where whether they liked it or not didn't really buy into whether Airbus renewed a $20 million contract with Siemens. We think that sucks, and we think that doesn't work, and we think the pain that's felt by engineers today is a result of that. So I'm not a systems engineer by training, I'm a mechanical engineer by training. And we've built our tool to be incredible and lightweight. We've built it to be self-serve, so there is zero training required. I think even with new software companies, there's 2 or 3 hours of training. For us, there is zero. And you should be able to pick it up and start using it and fall in love with the tool in a completely self-serve way. And that's driven every single one of our design decisions. It's can we build a better end user experience for user 1, user 2, the 10th user? And we believe that if there's enough love in the engineering team, and there's enough adoption in there, we'll win the decision makers at the end of the day.
Did that philosophy drive your hiring and how you constructed the team internally?
I don't think it did. I think engineers look for a lot of really sophisticated structures behind hiring. Mm-hmm. I think the reality of it is it's just really, really, really hard to build a great product.
Right.
That's what it comes down to. Like, does your software as a product, is it fantastic? And it's just so hard to pull that off that you've got to find the people that are the best at building products. So a lot of companies in the space start out with mechanical engineers, and the mechanical engineers write the code. And then they say, built by engineers for engineers. I don't treat that as a sign of success. I think you want the best software engineers in the world that have designed the most beautiful, interesting, awesome products across different verticals to come in and reinvent what software looks like for our industry.
Interesting. Well, this is great. Pari, we have to take a quick break. And when we get back, we'll talk a little bit more about your customer set. So stay with us. Space is the new frontier for cybersecurity. To quote the commander of the U.S. Space Force's Operations Command, cyber threats are unfortunately the soft underbelly of our global space networks. SpiderOak, the leader in space cybersecurity software, is dedicated to providing space operators with the solutions they need to protect hybrid space systems. Their Orbit Secure software uses a unique combination of end-to-end zero-trust encryption and blockchain distributed ledger, allowing missions to orchestrate and secure Earth-to-orbit, orbit-to-Earth transmission, communication, and storage of sensitive data across even the most complex and unsecure LEO and hybrid space systems. To learn how Orbit Secure can bring zero-trust security and resiliency to your zero-gravity environments, check out SpiderOak at www.spideroak.com. So Pari, give me a little bit of a flavor of the customers that are using your product today. I assume mostly commercial. Is there any type of government use case? Talk a little bit about that.
Yeah, absolutely. So we largely sell to the modern space and aerospace industry. Companies that are taking the old playbook, ripping it up, and moving really, really, really quickly. So most of our customers are in the US, in and around the LA area, and they're moving at an insanely quick speed, and they need a tool to help support them on that. We are one of the, we would argue, one of the best to use and the highest value of the new school engineering suite. And we have customers that are coming to us and ripping out our competitors mid-sprint, mid-cycle, which we never thought would happen, and moving over to Flow and absolutely falling in love with the experience of it.
What does your ideal customer look like?
So let's go back to what makes for a great Agile team. And I think it's really in that. So I speak a lot about this traditional to Agile transition. The first thing is systems engineering looks completely different in these modern teams. I was visiting one of our customers a couple of weeks ago. They design small modular nuclear reactors that the team are largely all ex-SpaceX. And I spoke to the CEO, Doug, and he leaned into me. We were speaking about systems engineering. And he goes, that's our secret, Pari. At Radiant, all of our engineers are systems engineers. We don't treat systems engineering as a discipline that sits in a corner, that does systems engineering work, and then the engineers do the design. We treat every single engineer as a systems engineer, wearing a systems engineering hat, taking a cross-functional approach to this. And to be able to do that every engineer in the team needs to be able to interact with requirements because that's the fundamental specifications that they need to hit. If you look at these modern teams, every product feature they need to build, let's take an EV, for example, cruise control. It doesn't just fit inside of batteries, and it doesn't just fit inside of software, and it doesn't just fit inside of mechanical, and it doesn't just fit inside of radar systems. It sits across all of these different teams, and you need this cross-functional collaboration to make that happen. So our ideal customer are what we call agile teams who have a real need to move quickly, who have cross-functional collaboration, and requirements are used everywhere.
So let's talk about NASA for a second.
All right.
So Apollo era, I mean, one would argue, I mean, I'm sure you could argue either side of this, what I'm about to say, but at the time, I mean, that is systems engineering in all its glory, right? Apollo era, whatever, 1 million people working on the Saturn V and the space program. What's to talk about like what engineering was like then and how it's evolved and how it became, got into sort of the funk that we've been talking about.
This is the dream question, by the way. I think people really misunderstand this. Apollo, Saturn V vehicles, going from Mercury to Gemini and Gemini to Apollo, each one of those things being a testing ground for different systems and then leveling them up. Also, as I mentioned earlier, the SR-71 Blackbird. When we designed the Blackbird, when we designed the Apollo vehicles, we didn't have computers. We didn't have CAD. We didn't have simulation. We didn't have any fancy of the modern tools that we have today. And we were still able to move at an insane speed. So what made that great? What can we learn from that? And then does today map to that, or is today different? Well, the first thing I would argue is that engineering back then was a lot less siloed. Everyone was on pen and paper. So we didn't have these tool silos to, hey, my stuff lives in a CFD and you don't really understand that, so I need to build a Word report and you haven't got access to the license for it, so you can't go into it. We didn't have any of those tool barriers existing. So it was much easier to cross-functionally collaborate. And what's really, really obvious about these systems is they needed to move quickly. So every engineer needed to be part of those cross-functional trade-offs. Ultimately, if you build the best possible propulsion system, you'll probably build a worse rocket or a worse airplane because you've over-optimized in one domain and you haven't found the core thing that crosses through everything. So I'd argue that Blackbird, Apollo looked a lot more like modern systems engineering than 2000s NASA systems engineering. That's a big argument. Big argument number two is the reality is things have got much more complex, not less complex. If you look at the software stack inside of a modern aerospace vehicle, the complexity behind it is insane. But also our complexity has increased not just in one domain, but across different domains. So today, if you take a small change to the Falcon 9 engine, right, and you make a small change to one of the holes in the injector, well, that will cause complex changes downstream in the combustion and the pressure profile, which causes changes in the structures, which then causes changes in, the thrust vector control, which causes changes in the software. Each one of those changes causes a chain reaction changes in other places. And all of those things are happening across disparate teams and disparate tools, which creates the issue that we have today. So I'd argue, although we've taken a step back in the cross-functional collaboration, the complexity behind engineering has actually increased tenfold or 100-fold, which has made the problem as crazy as it is today.
Yeah. Well, it's also interesting back in, I think from like design to launch, Saturn V was 6 years, which is like insane. Anyway, so going back to your point, like what does a modern engineering team look like? Like, or what should it look like? Yeah. Maybe that's the better question.
Yeah. Awesome. So the first thing I'd say, and engineers don't like this answer, and I hated this answer a couple of years ago, is it's really requirements driven. And the reason for that is today it's so inconceivable to capture all the complexity of a modern program in your head. You kind of have to command and conquer. And the way you command and conquer is you say, here are my top level specifications, my requirements, and I break them down and break them down and break them down. And then when a change inevitably happens, you can say that requirement changes, that requirement changes, that requirement, so we need to make a change to the engines over here. And requirements are really used front and center as a way to break down specifications and to collaborate. The second big thing that I see modern teams do is that we are okay with being wrong. NASA can't really afford to get things wrong, right? They're sort of taxpayer funded, very, very large teams, very long cycles. If the SLS is in design for 10 years, they can't really then afford to fail. But what modern teams can do is afford to go, hey, we're going to have some assumptions. We're not going to get everything right, and we're not going to try and model everything in our heads or in a computer. We're just going to try it. And then once we've tried it, we're going to take those learnings and feed them into the next vehicle, and the next vehicle, and the next vehicle. And the faster our cycles are, the faster we can learn as a team, the better we're going to be in terms of building that institutional knowledge, but also building better products.
Yeah. Let's talk about your competition for a second.
Yeah.
How do you differentiate from other engineering collaboration tools, and can they all coexist with one another? Is the market big enough?
Good question. I've got controversial takes from both of them, unsurprisingly.
Good. Be as controversial as you'd like. We like that here.
Great. So the first thing to say is there is a wave of modern software coming out today, and I personally believe, and I certainly know that sort of my friends who run other software companies personally believe, that the industry is going to be the best software for X and not one tool to rule them all. This idea that Siemens sells, that, hey, I'm going to sell you a PLM for $1 million a year, and I'm going to give you every single bolt-on that you ever need, and they're not going to be great, isn't the way to go forward. If you look at any other industry, you have the best version control software and the best testing software and the best ticket software, and all these things natively talk to each other. And that means individual companies can actually focus on making the absolute best experience for a specific workflow. So when I speak to Karan at First Resonance, who's building Ion, when I speak to Laura at Epsilon, we all agree that, hey, we want specialization, not generalization, but our tools natively need to be able to integrate so our customers have the best possible experience. So I don't believe that the market is too small, and I don't believe there'll be one player to rule them all. I think we all win, and the rising tide lifts all the boats, if we take that philosophy that we're going to build the best at X and not try and do everything. In terms of competition, we have competition. 3 or 4 years ago when we started the company, we didn't have that much competition, and today we do. Unfortunately, what we see is these companies are trying to replicate Siemens as opposed to meaningfully differentiate from them. So they've taken the same philosophy of top-down enterprise sales. They've taken the same philosophy of sell to the buyer, not the user, and they've built really bad experiences. And when you start off with a really, really clunky bad experience, it's very, 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 very difficult to unpick that whilst adding more features and more functionality that decision maker needs. So when I look at our competition, I don't really worry, because I think what we did right at Flow is we took a couple of years to get the core loop and the core experience around requirements magic. And once we got that right, it was pretty easy for us to grow in functionality and in feature set quite quickly.
So I have a thesis that I know you're going to disagree with, but I want to hear your perspective. You're kind of answering it. You're answering it a bit in what you just said, but I believe that software collaboration tools focusing on hardware and engineers at scale are going to start to look very similar. And here's why. I think if they were just building, sort of like, for specialization, like you mentioned, I think maybe not necessarily would have happened, but naturally what you're having is like, you're venture backed. A lot of these companies are venture backed.
Yeah.
VCs are looking for big markets. They want to see growth. They want to see, you move into another area or whether it's a vertical or, whether it's a verticalization or horizontally. And at some point that pressure is going to force folks to start like moving into each other's like sandboxes. Do you agree that that's a reality, or do you think like specialization creates big enough markets that it'll satisfy the VC investors?
I think there's a misunderstanding of how big the market is. I think people really don't get that. I think when we think about modern space, we think about Hawthorne, and we think about El Segundo in LA, and we think about companies in and around that area. And Wave is much, much, much bigger. We fundamentally believe one thing, which is in the next 10 years, every hardware company in the world is going to need to take an agile approach, or they will die because their competition hasn't beat them. That's our fundamental belief. So we think all of the established players will need to compete or die. And you've seen that happen in the EV industry with Ford. Ford transitioned from a much more old school approach to an EV, agile, modern, year-on-year approach, and they pulled it off. That same thing is going to happen in the space industry. You're seeing ULA go on the market. You're seeing things change as a result of these competitive pressures. And the market's really big. So point number one there. What I do agree with you is VCs want a growth angle. They want you to say, hey, we're going to win everything for everything, and we're going to be the one tool to rule them all. What I would argue is that in modern cross-functional teams, if you try and build for everyone, you end up diluting and building for no one. If you try and build for a systems engineer and a manufacturing engineer and a production engineer and a test engineer, those people are so different and their day-to-day lives look so different that you end up building a terrible experience for everyone and not the best experience in the world for a small subset of those users that can then integrate natively with other tools. That's what we've seen play out in design. That's what we've seen play out in software engineering. That's what we've seen play out in gaming and animation. I think that same pattern is going to hold true for our industry.
So speaking of venture capital, you have raised venture capital. About a year ago, you raised a seed round. I believe it's around $8.5 million from a number of really great investors. Maybe talk a little bit about those investors and how you're partnering with them.
Yeah. So as you mentioned, Flow Engineering raised an $8.5 million seed round, and we announced it last year. We're really lucky to have some of the best VCs and angel investors in the world. We have the former CEO of Unity, which is the largest video game engine, which is the tool used by video game designers in the world. We have some C-level execs at companies like Figma. We've got really the best of the best in the world backing Flow and really betting on us to be a massive, massive success. Raising VC money, honestly, for us has been great because I would rather Flow dies than Flow turns into Siemens. You know, I don't mean that in the size of Siemens. Obviously, we want to be a huge success and we want to be a massive company. But I think what I'm seeing with our competitors is that they are becoming, they try and compete with IBM doors. And then feature by feature, week by week, month by month, they build the same functionality in the same way and they dilute the core offering. So I would much rather we build the best product in the world that's extremely spiky and win it in the next 5 years, and we completely change everything about everything. In the engineering industry, or die trying. And I'm very okay with those odds.
How do you think the financing landscape has evolved for software companies building for hardware? So I say that a little bit with the basis that right now it's pretty hot, right? Yeah. Like, how has that evolved, and where do you think it's going?
I don't really follow the whole VC trend cycle. I did a while ago. I'm over it. I've got less time than I have in the day to follow VC news. Obviously, there has been a bit of a downturn, and obviously this has taken a massive hit to our customers, who are hardware companies that need to raise large amounts of CapEx intensive rounds. And that's going to have a knock-on consequence on the industry. The good news about the American market is the DoD is a customer. The DoD is always going to have need, and they're always going to have budget, and they're always going to buy from these customers. So the DoD sort of has our customers back in that side, and that same pattern plays out in other companies that are non-US too. In terms of software for hardware, who knows? Like, maybe it's hot today, maybe it's not tomorrow. I think what we focus on is building the best possible product for our customers, and we think we'll make it or die doing that.
Good answer. So where are you building? So I know you have, I'll let you answer that question.
Yeah, so we are based in LA and London. I spend about a half to a third of my time in LA with our customers. The engineering team, I'm born and raised in London, and the engineering team are out here. We have some of the best software engineers and designers in the world working at Flow. And I think you've seen that in the pudding. You've seen that in the product. We're a very, very small team. We're only about 8 people right now. And yet we are one of the fastest moving software teams in our industry. We've gone from basically a blank sheet of paper a year ago when we did a bit of a reset internally to one of the most powerful requirements management tools built for agile teams in the industry today. And so much so that our customers are moving from our competitors mid-sprint to Flow, and they're really seeing the results of that. So we couldn't be more happy with where we are.
What's it like building part of the business in London? And what's driving that decision to continue building in London?
I mean, London is, I think in the modern world, you can build the best company in the world anywhere. What's really important is to have close customer ties with your customer, close personal relationships with your customers, and to have those ties there. And as a result, I don't sleep very much. And I have an incredible amount of jet lag, and my calendar goes from 8 a.m. in the morning until 12 midnight every day. But I get such a kick out of speaking with people designing hydrogen-powered airplanes and modern satellites and in-space thrusters that we could eliminate.
So what does the world look like if every hardware company is using Flow?
Great question. Great question. Are you familiar with GitHub?
Yep.
Are you familiar with CI/CD?
I'm not.
Okay. So let's talk about both of these things and maybe introduce them to the listeners that don't know.
Sure.
Most software engineering teams in the world use a version control collaboration software. GitHub, GitLab, the two big players in that industry. What's also happened in the software engineering industry is that we've built this automated testing pipeline, and it's called CI/CD. It stands for continuous integration and continuous deployment. And this change has enabled us to move from the old school Windows era, where we shipped a release every year or a couple of years with a large QA team. That's actually how hardware looks today. To this modern era, where when you use Figma or you use a design tool or you use your Gmail, you're getting updates 3 or 4 times a day. We've enabled the pace of change to go much, much faster. And the way we've done that is we linked our design to our tests or requirements. And every time anyone makes a change, we automatically test whether our requirements are working or failing. Now, if you turned off GitHub today, the entire internet would break. I can't demonstrate how fundamentally important it is that modern software teams have access to these tools and can automatically test 3, 4, 5 times a day in an automated way with massive complexity systems. If you turn that off, the entire software engineering industry slows down and the pace of innovation slows, and we get a lot more risk averse, and we spend 10 years trying to get it right, which is where we are today. I think our mission as Flow Engineering is to try and accelerate the pace at which every hardware team in the world works. And if we can do that, we can help satellites get to market 5, 10, 20% faster. We can help thrusters, we can help aeroplanes, we can help nuclear reactors. There are so many fundamental problems to be solved in the industry today. We're doing it with much less capital than we thought we'd have 2 or 3 years ago, given the downturn. And the best teams in the world will do it with speed and efficiency. And we just want to be a small part of that journey.
If you weren't building Flow, what would you be building? Back to rocket engines?
It's an impossible question. I used to think of it myself as a mechanical engineer that was doing the software stuff. I think if I went to my team or my customers and said I was a mechanical engineer today, they'd laugh me out the room. I've definitely lost my edge when it comes to sitting in front of a CAD system and building geometry. I think I would go again and I'll build software for hardware, and I just solve the next problem, the next problem, the next problem. I love the ability to serve the market that I'm in love with, but to do it in a way where I can ship updates 2, 3, 4 times a day. That just makes my day.
So you see a lot of different hardware companies, right? Building a lot of complex problems or solving a lot of complex problems. Yeah. What of those companies, and you don't have to name a company specifically, but like, is there a product? Is there someone building something that's particularly interesting to you or exciting to you that you're really rooting for?
I mean, they're all exciting to me. If I had to sort of highlight a couple of key problems that I think are really our era's problems, I'd say they're in energy. And specifically, we're seeing a tide change in the nuclear industry. So I see companies that are attempting to do fusion. Fusion is one of the things that people laugh at today, but it is going to happen, and it will be a big part of our journey over the next 100 years. And someone will solve it, and they're not going to solve it with the old school philosophy. They're going to solve it in this new school way, and the timing is right for it. But I also see more traditional approaches, SMRs, small modular nuclear reactors. China just turned on their first wave of SMRs and were first to market with that. And we're seeing the US move really, really, really quickly to compete with it. We're seeing the same sort of programs come out of the UK with Rolls-Royce. So those are just a couple of examples that I get really personally passionate about.
Yeah, the U.S. unfortunately has a big regulation problem that we still need to sort through, but I agree with you. The innovation and the technology is definitely there. Okay, the most important question of the day, probably the most controversial. What London football team do you support? A club, I should say.
I don't get it. I don't get any of it. I'm weirdly immune to anything sportsy. I think
spoken like a true engineer.
Yeah, you got me.
All right. Well, I'm actually a little surprised to hear that, but There's a few teams that you could choose from, but maybe next time you're on the show, you'll have changed your mind.
I'll get encyclopedia out. I'll brush up on my research.
There you go. Well, Pari, it was a pleasure to have you. Thanks for all your insights and your interesting takes on the industry. We appreciate having you and looking forward to having you back one of these days.
Talk to you soon. Bye.
Thanks. Bye.